So today we are going to start with problem set 3. Now question number 1 from problem set 3 is of multiple choice question. So that question you have to solve on your own. If you have any doubt you can ask anytime. Now we are going to start with question number 2. So let's read the question. Line L touches a circle with center O at point P. If radius of the circle is 9 cm, answer the following questions. Question number 1. What is distance OP and why? Second one. If distance OQ is equal to 8 cm, where does the point Q lie? Question number 3. If distance OR is equal to 15 cm, how many locations of point R are on line L? At what distance will each of them be from point P? Now in your textbook, the third question, it is given as distance PQ is equal to 15 cm. So you have to do the correction here. It is not distance PQ, it is distance OR. Okay. Now let's start with the solution. Now what is the first question? You have to find distance OP and you have to write the reason for your answer. Now to find the distance OP, first we will draw segment OP. So if you draw a segment OP, you will find that OP is nothing but radius of the circle, and we know the radius of the circle is 9 cm. So let's write down here, radius of the circle is 9 cm. It is given to us and OP is the radius. Therefore, distance of OP is equal to 9 cm. So this will be a final answer. Now let's move on to the next question, that is, if distance OQ is equal to 8 cm, where does the point Q lie? Now, if distance OQ is equal to 8 cm and distance OQ, that now 8 cm, we know that radius is 9 cm. So we can write here distance OQ is less than radius. Yes. Therefore, point Q lie in the interior of the circle. Now we know that if any point is having distance less than the radius of the circle, then that point will be in the interior of the circle. And if the distance between the point and the center is more than radius, then that point will be in the exterior of the circle. So here point Q, the distance between center and point Q is less than radius, so point Q is in the interior of the circle. Now let's move on to the third part of this question, where distance OR is given as 15 cm and you have to find the location of point R. So here if you consider point R on line L, then there will be two possible locations of point R. So one location will be on the left side of this line OP and the other location will be on the right side of this line OP. Yes. So let the locations be R and R dash. So these are the two locations we have. Now let's consider triangle OPR. So in this triangle, what you get? Angle OPR is equal to 90 degree, because we know that radius is perpendicular to the tangent. That means by tangent theorem we can write here angle OPR is equal to 90 degree. Therefore, by Pythagoras theorem we can write OR square is equal to OP square plus PR square. Now substitute the values here. OR is given as 15 and OP is given as 9. So you will get here 15 square is equal to 9 square plus OR square. Therefore, OR square is equal to 15 square minus 9 square, that is equal to 225 minus 81, that is equal to 144. So if you find out the square root on both sides, you will get OR is equal to 12 centimeter. That means similarly you can find the distance of OR dash, this distance, that will also come as 12 centimeter. Therefore, you can write each location of point R will be at the distance of 12 centimeter from point P. So on any side of the line OP, if you consider this point R, then the distance between the center and point R will be 12 centimeter. I hope you all have understood this question. Now let's move on to the next question. That is fourth one. In figure, O is the center of the circle. Segment AB, segment AC are the tangent segments. Radius of the circle is R and length of AB is equal to R. Prove that quadrilateral ABOC is a square. Now if you observe this figure, you can see here segment AB and segment AC. These are the two tangent segments drawn to this circle with center O, and it is also given as length of AB is equal to R and radius of this circle is also R. So let's draw the radius here. So let's draw OB and segment OC. So what you can write here? OB is equal to OC is equal to R. Reason is radii of the same circle. Write this equation as equation 1. Now length of AB is given as R. So that will be your second equation. AB is equal to AC by tangent segment theorem. Length of AB will be equal to length of AC. So write this equation as equation 3. So if you compare equation 1, 2 and 3, what you can write? OB is equal to OC is equal to AB is equal to AC, because all have the value as R. Therefore, we can write here quadrilateral ABOC is a rhombus by definition, because all sides of this quadrilateral are equal. Now angle OBA is equal to 90 degree, because here this AB is the tangent to this circle and OB is the radius, and we know that radius is perpendicular to the tangent. Therefore, a rhombus is a square if one of its angle is a right angle, that you all know. Therefore, we can write here quadrilateral ABOC is a square. So this is the proof for this question. I hope you all have understood this. Very simple sum. Now let's move on to the next sum here. Fifth one. In figure, quadrilateral ABCD is a parallelogram. It circumscribes the circle with center T. Point E, F, G, H are touching points. If AE is equal to 4.5, EB is equal to 5.5, find AD. So let's start with the solution here. AE is equal to 4.5 and EB is equal to 5.5. It is given to us. Therefore, AH is equal to AE. AH is equal to AE is equal to 4.5. Similarly, we can write BF is equal to BE, that is equal to 5.5. Let DH is equal to DG is equal to X, because we don't know any of these value. Similarly, CG is equal to CF, that is equal to Y. All these equations, reason you can write as tangent segment theorem, because all these are tangents drawn from point outside the circle. Now quadrilateral ABCD is a parallelogram. It is also given to us. Therefore, AB is equal to CD. These are the opposite sides of this quadrilateral, because we know that opposite sides of a parallelogram are equal. Therefore, AE plus EB is equal to CG plus GD. Reason you will write as points A, E, B and point C, G, D are on the same line respectively. Therefore, substitute the values here. AE is given as 4.5, EB is given as 5.5, that is equal to CG we have assumed as Y and GD we have assumed as X. So you will get here X plus Y is equal to 4.5 plus 5.5 is 10. Write this equation as equation 1. Now as we have written AB is equal to CD, we can write AD is equal to BC. These two are also opposite sides of the parallelogram, so they are also equal. Therefore, AH plus HD is equal to BF plus FC. Reason you will write as points A, H, D are collinear and point B, F, C are also collinear points. Now substitute the values here. AH is 4.5, HD is X, that is equal to BF is 5.5 and FC is Y. So you will get here X minus Y is equal to 5.5 minus 4.5, that is equal to 1. Write this equation as equation 2. Now adding equation 1 and 2, we will get X plus Y is equal to 10, X minus Y is equal to 1. Add these two equations, you will get 10 plus 1 is 11, and here plus Y minus Y will get cancelled. So you will get X plus X as 2X, that is equal to X is equal to, therefore X is equal to, now shift this 2 to the other side, you will get 11 upon 2, that is equal to 5.5. Therefore, DG is equal to DH is equal to 5.5 because we have assumed their value as X. Now AD is equal to AH plus HD. Reason is points A, H, D are on the same line. Therefore, AD is equal to, substitute the values of AH and HD, 4.5 plus 5.5, that is equal to 10. So this will be your final answer. AD is equal to 10. Now let's move on to the next question. Sixth one. Circle with center M touches the circle with center N at point T. Radius RM touches the smaller circle at S. Radius of circles are 9 cm and 2.5 cm. Find the answer to the following questions. Hence find the ratio MS is to SR. So here you have to find 4 values. First one, find the length of segment MT. Find the length of segment MN. Find the measure of angle NMS, and also you have to find ratio of MS is to SR. Okay, so let's start with the solution. Draw segment NS. So here we are going to draw segment NS. So what you can write here? Radius of the larger circle is 9 cm. It is given here. Therefore, MR is equal to MT is equal to 9 cm because MR and MT, these two are the radii of the same circle. Now radius of the smaller circle is given as 2.5 cm. Therefore, NS and that is equal to NT, that is equal to 2.5 cm. Yes, now we can join these line N, M, N, T. So what you will get here? M dash, N dash, T, that is these 3 points are on the same line. So reason is by the theorem of touching circles. Therefore, MT Mn plus Nt, that is equal to MT. Reason you will write as points M and T are collinear points. Therefore, Mn plus Nt we know as 2.5 centimeter because Nt is the radius of the smaller circle, that is equal to Mt. Mt is nothing but the radius of the bigger circle, so it will be 9. Therefore, Mn is equal to 9 minus 2.5, that is equal to 6.5 centimeter. So first we got the length of Mn. Now we have to consider triangle MSN. So in this triangle, what you can write? Angle N MSN is equal to 90 degree because NS is the radius and MR is the tangent here, and we know that any radius is perpendicular to the tangent by tangent theorem. Now by using the Pythagoras theorem, what we can write here? Mn square is equal to ms square plus ns square. Now substitute the values. Mn is 6.5 square, that is equal to ms square plus ns is 2.5, that is equal to 6.5 square minus 2.5 square, that will be, therefore ms square is equal to 6.5 square is 42.25 minus 2.5 square is 6.25. So if you minus 6.25 from 42.25, you will get 36. Therefore, ms is equal to 6 centimeter. If you find out the square root on both sides, you will get ms is equal to 6 centimeter. Now, ms plus sr is equal to mr because m, s, r are on the same line. Therefore, substitute the values here. Ms is 6 plus sr is equal to 9. Therefore, sr is equal to 9 minus 6, that is equal to 3 centimeter. So we got here ms value and sr value. You can find the ratio of these two. Therefore, the ratio of ms is to sr is equal to 6 is to 3, that is equal to, now if you 6 upon 3 you can reduce to the smaller value, that is equal to 2 is to 1. So the ratio of ms is to sr is equal to 2 is to 1. Hence we have solved this sum. I hope you all have understood this. This was very simple sum, only you have to understand it stepwise. Now let's move on to the next question. In the adjoining figure, circle with centers x and y touch each other at point z. A secant passing through z intersects the circles at points A and B respectively. Prove that radius XA is parallel to radius YB. Fill in the blanks and complete the proof. Now this question is activity based question. Answers, half the answers are given to you. You only have to fill in the blanks. Now let's start with the solution. First is given as construction. Draw segment XZ and you will write as YZ, that will be your first fill in the blanks. You will draw segments XZ and YZ. Now let's start with the proof. By theorem of touching circles, points X, Z, Y are collinear. From the figure you can write down. So they are collinear. So this will be your second fill in the blanks. Therefore, angle XZA is congruent to angle BZY. Reason you will write as opposite angles. Now, let angle XZA is equal to angle BZY is equal to E. Write this equation as equation 1. Now seg XA is congruent to seg XZ. They are radii of the same circle. Therefore, angle XAZ is equal to angle XZA, that is equal to A, because these two angles are the opposite angles of the congruent segments. Therefore, they are also equal. The reason you will write as isosceles triangle theorem. Write this equation as equation 2. Similarly, segment YB is congruent to segment YZ. Yes, then their opposite angles will be also equal. And reason you will write as radii of the same circle. Therefore, angle BZY is equal to angle YBZ is equal to A. Yes. Reason you will write as isosceles triangle theorem and write this equation as equation 3. Now from equation 1, 2 and 3, what you can write? Yes, angle XZA is equal to angle YBZ, because here in equation 1 also you will have angle XZA and equation 2 also you will have angle XZA. So here you will get angle XAZ is equal to angle YBZ. If you consider seg XA and YB as the parallel line and XY as the transversal, then these two angles will be alternate angles. Therefore, radius XA is parallel to radius YB. Reason is alternate angles test for parallel lines. Yes, I hope you all have understood this. Hence, we have proved the statement. So with this, we are going to end this session here. And remaining sums we will do in the next session. Now let's move on to the last part of this session, that is assignment. Here I have given you two questions from problem set 3, third question and 8th question. So in the figure, M is the center of the circle and seg KL is the tangent segment. If MK is equal to 12, KL is equal to 6 root 3, then find radius of the circle and measure of angle K and angle M. So this sum is very simple one. Here ML is perpendicular to this tangent segment KL. So here you will get 90-degree angle. So here you can apply the Pythagoras theorem. So rest all you can, with this you can find the radius and then you can find the measure of angle K and angle M. And next question is question number 8. In the figure, circle with center X and Y touch internally at point Z. Seg BZ is a chord of bigger circle and it intersects smaller circle at point A. Prove that seg AS is parallel to seg BY. To solve this question, you have to do one construction. You have to join this YZ. So I hope you all have enjoyed this session. Thanks for watching this video.